Hello friends, so this is Dheeraj again here, and I have come here to discuss with you a couple of questions which was asked by one of our students. So I thought of making a video out of it because these are some unique type of questions. So let us take these one by one and let's see how we can analyze this particular scenario. Okay, so you can see the question in your screen. Okay, let us first read it. The force of buoyancy exerted by the atmosphere on a balloon is B. Okay, in the upward direction. So of course, force of buoyancy will be in upward direction, and it remains constant. The force of air resistance on the balloon acts opposite to the direction of velocity. Okay, and is proportional to it. So there are two forces. One force is force of buoyancy on the balloon. So if you draw a balloon, suppose this is a balloon, okay? On this balloon, there will be a force of buoyancy. That is always capital B. Fine. It acts constantly. And there is a force of air resistance on the balloon that acts in the opposite direction of the velocity. Okay. So it depends on which direction is the velocity. Depending on that, the force of resistance will be acting on it. Okay. And the magnitude of force is proportional to the magnitude of velocity. Okay. The balloon carries a mass capital M. So of course, since it has a capital M mass, so it will have mg force downwards. Okay, and is found to fall down near the earth's surface with a constant velocity v. So this balloon is moving down with velocity v. Okay, so now that we know the direction of velocity and magnitude of velocity, I can show the direction of the force of air resistance. Okay, so it will be acting in opposite direction, which is upward. So this force is equal to constant time velocity. Okay, now since the balloon is moving with a constant velocity, acceleration is zero, right? And since acceleration is zero, all the forces will be balanced, right? So I will be able to write down here as cv plus b minus mg, which is a net force, is equal to mass time acceleration. Now velocity is constant, so acceleration is zero. So this is equal to zero, right? So this is our first equation, and it represents the scenario number one. Now what happens is you need to find out how much mass should be removed from the balloon so that it starts rising with constant velocity v. So with the same velocity with which it was going down, now the balloon is moving up with the same velocity. Okay, we need to find out how much mass should be removed. All right, so let us draw a representation of second scenario. So here is the second scenario, the same balloon. Okay, the same balloon. Since we are assuming that it is the same balloon and the volume does not change, the force of buoyancy remains B only. Okay, and assuming the mass is now m dash, because we have already thrown some mass down, so the gravity force will be m dash g. Okay, and now this balloon is moving up with velocity v. Okay, now tell me which direction the force of air resistance will be. Force of air resistance will be opposite to the direction of velocity, so it has to be down, and it will be of the magnitude which is equal to the previous scenario, because velocity is same, as in the magnitude of velocity is same. Okay, now if I write force balance equation for the scenario number 2, I'll be able to write it as B minus C times V minus M dash G is equal to 0. Okay, so this is our second equation, right? Now we need to find what? We need to find out the value of m dash minus m, as in how much mass you need to throw away. Okay, so if you subtract 1 and 2 equation, what you'll get here as 2 times CV minus of m minus m dash into g is equal to 0. Okay, so delta m, which is equal to m minus m dash, will be equal to what? It will be equal to 2CV divided by g, right? Now look at the first equation. If you look at the first equation, you'll see that C times V is equal to mg minus b. See, the value of C is not given, so I cannot just leave the answer in terms of C and V. Okay, so that is why I need to substitute value of CV from the first equation over here. So delta M will become equal to 2 by G times of mg minus b. Okay, so this is how you solve this particular question. So I hope you have learned something today, and in case you have any doubts, please feel free to get in touch with us.